Good morning, students. Today our topic will be salts. Now, what is salt? Salt is a compound that is formed by partial or complete replacement of ionizable hydrogen atom by metallic ion or ammonium ion. That means ionizable hydrogen atom will be replaced by metallic ion or ammonium ion. Let us take one example to understand. Suppose there is a compound called sodium nitrate reacting with sulfuric acid. Now, when the temperature is taken below 200 degrees Celsius, this ionizable hydrogen atom will undergo partial ionization, or there will be partial replacement, which will combine with this metal ion and will form a salt. It will not combine, actually it will be replaced by this metal ion and will be formed a salt. This is the salt going to be formed by the replacement of this hydrogen atom with the help of sodium ion. Sodium ion is a metal ion. Now, as a result of this, sodium hydrogen sulfate, which is an acid salt, is formed along with HNO3. Now, this is an example where we find partial ionization of hydrogen atom has taken place. We can also see an example where there will be complete replacement. When the temperature is increased to more than 200 degrees Celsius, there will complete replacement of this hydrogen atom to form a salt Na2SO4, that is sodium sulfate, and plus HNO3. So in both cases we find salt is formed either by partial replacement or complete replacement of hydrogen atom. So this is the main definition we find for salt. Now, what other things we are going to study here is the laboratory preparation of some salts, which again is very important for your board exam. Let us see how can it be. So we are going to move to next topic, which is laboratory preparation of salts. So when we are preparing salt in the lab, there are various things that we have to take care of. The method should be quite safe. The salt so formed should be viable. Some suitable method we are going to see in order to prepare salt in the lab. So the first method is synthesis, which is called direct combination. So the name of the salt that can be prepared using this method is also very important, and the most common salt that we find is ferric chloride. Ferric chloride can be the example. We write FeCl3. Now, how can the equation be written to prepare this prepare salt using this method. As you can see, the method itself says it is a direct combination. That means the two elements you can see in the salt can be directly combined. So we can have iron as one of the element, the other element is chlorine. When these two elements combine, we can obtain a salt called ferric chloride, and this is a direct combination method. Next method will be by the action of dilute acid on an activator. Let's come to that. Now from the salt itself we can make out whether that salt can be prepared by this method or not. It means to say that the salt must contain one active metal in it. For example, if I take FeCl2, that is ferrous chloride, see the difference. In the first case we had ferric chloride and here we have ferrous chloride. So this will be coming under this method. So how can this be prepared? That is ferrous chloride. You can see in this salt, iron what is used is an active metal. So the salt that contains an active metal, we can put it in this category where salt can be prepared by the action of dilute acid on an active metal. So here we have the equation Fe plus HCl, where iron is an active metal and it is dilute acid, and it gives FeCl2 plus hydrogen gas is released. And this method is also called displacement method, because you can see hydrogen is displaced by this active metal. Similarly, we can have another example of zinc sulfate. In this salt also we find zinc as an active metal present, where zinc can react with H2SO4 to give or to form a salt zinc sulfate plus hydrogen gas. So we have these two salts. We can have many other salts also, but we have to see that salt must contain an active metal. Only then this method can be considered to be a suitable method to prepare that salt. Let us come to the third method. And the third method is action of dilute acid on an insoluble base. Please see. We have the third method, action of dilute acid on an insoluble base. And this method can also be called neutralization reaction. And you know, neutralization reaction is the reaction between acid and base to form salt and water. But the base to be taken should be an insoluble base. Now once again from the salt we can easily make out whether that salt can be prepared this method or not. For example, copper salt like copper sulfate and copper chloride, easily we can use this method to prepare it. The reason is, please see here, you come to know what the reason is, like CuSO4, and it is this copper, that case, that can be changed to an insoluble base where the reaction will be with an acid containing sulfate ion to give the salt. So the equation can be written as copper hydroxide and plus H2SO4. You can see copper is taken as copper hydroxide, which is an insoluble base, and H2SO4 is the acid which gives copper sulfate and water. If there is copper chloride, we may write copper hydroxide, or we can take copper oxide this time, and the acid to be taken should contain chloride ion. So we can take hydrochloric acid, and the reaction gives copper chloride and plus water, H2. So these are the different methods. We have two more methods to prepare the salts that we are going to discuss in the next class. Thank you.